이데일리 글로벌 AI 포럼 2025의 기조 강연이 우선 있겠습니다. 기조 강연은 세계 AI 산업을 주도하는 핵심 국가들의 전략을 주제로 저희가 준비를 했습니다. 우선 첫 번째 국가는 미국입니다. 글로벌 AI 시장을 이끄는 혁신 리더십, 미국을 주제로 스테파니아 드루가 전 구글 딥마인드 AI 연구과학자이자 현 사카나 AI 연구원님과 캐런 문 스팽글AI 공동창립자 겸 최고사업책임자님께서 발표 이어갈 예정입니다. 먼저 스테파니아 드루가 전 구글 딥마인드 AI 연구과학자이자 현 사카나 AI 연구원님을 무대로 모시고 첫 번째 기조 강연 이어가 보도록 하겠습니다. 여러분들의 뜨거운 박수로 무대로 연구원님을 모셔보겠습니다.
Good morning. 안녕하세요. Is that how I say? Hi. Good morning. Thank you for joining us today and thank you for the invitation. My name is Stefania Druga. I am Romanian. I'm not American. And I'm currently living in Japan, Tokyo. Very happy to be here with you today. We're going to talk a lot about concrete projects and research that are currently being run in pushing the frontier of AI for science. So you probably heard the term AGI mentioned this morning, artificial general intelligence. I'm not a big fan of that term because I think it can mean a lot of things and for different people. So I think some of the most promising discoveries that are happening right now in AI research and AI applications come from AI for science. And I'm going to give you some examples. So I was very inspired by this project done by my colleagues at DeepMind, where they built the first AI co-scientist. And what the system does, it allows researchers like myself to be able to come up with a hypothesis or a problem, and then have an entire system of AI agents that go and search the web and see what are other research projects that were similar. What are possible other avenues to explore the same problem? Write code, test those hypotheses, have an agent that can rank all the solutions. Everything is orchestrated and is happening under the hood, and then the researcher is being presented with a couple of avenues for exploring further and options. So this is actually using the Gemini 2.5 model, which is a model I worked on during my time at DeepMind. And this was the first implementation of an AI co-scientist, like using AI to support scientists. So from this example, what they showed is that we can actually recreate prior scientific discoveries that took many years. This data was not part of the training, so the model couldn't know what the solution is. So in the real life, when researchers were trying to find a novel gene transfer mechanisms to address like our resistance to antibiotics, it took them more than 10 years to come up with this novel gene transfer mechanism. The AI scientist system was able to reproduce the findings in 2 days without having access to the data. But then it's not just about reproducing and showing that the systems can deal with prior AI discoveries. It's about creating new AI discoveries, new science discoveries. So let's talk about fibrosis, which is like a liver disease. Using the AI co-scientist, researchers found new drug treatments for liver fibrosis. They took the formula given by the system and tested it in the lab. So it actually worked in the lab in treating real people. So coming up with new drugs, new treatments. So right now, these systems of AI for science are being used for drug discovery. They're being used to address bacterial resistance. They're even being used to optimize the AI systems themselves. So Google is using the AI scientist to come up with better ways to use compute and design chips. So across the board, this AI for science ecosystem is growing extensively. And we heard this morning, I think it was the head of the Chamber of Commerce that mentioned the trade-off between scale and speed, right? When we talk about scale, there's another important thing to consider, which is sustainability. These large models, Gemini, GPT-5, the largest like frontier models, are very, very compute hungry. It costs a lot of money to run the inference these models need on huge data centers. And yes, we're building a lot of these data centers around the world, including here in Korea. But there is a carbon footprint, so there is a sustainability issue that comes with that. We're not going to be able to build all the data centers we need as fast as we need them with the current architecture that we are using for large language models. So we need to come up with new architectures, alternatives, that are more sustainable and environmentally friendly, and that are open source, that can be audited by independent parties to make sure they're ethical and safe. So my team at Sakana, part of the slide is covered, is actually exploring lots of these novel architectures. How do we use models inspired by nature, like evolutionary algorithms from nature, to come up with better solutions and new algorithms? For example, we had a system called Shinka. So what the Shinka Evolve does, and I don't know if we can fix the slide, so part of my slide is not covered by this black square. I don't know if that's possible. The Shinka Evolve, what it does, it actually takes a lot of the programs that are being built with the AI scientists, it mutates them, and it tries to find the best candidate for a given problem by the scientist. But it is more efficient to do this than using a large language model. And it does that with not comparable budget in terms of compute. It's a much, much smaller model, and it's able to achieve the same results. And actually, our team at Sakana used Shinka to win a competitive programming competition. So they were able to use this new evolutionary algorithm to beat the best programmers by using the system and collaborating with the system. Another example, and this is very recent, this was just launched last week by Edison Scientific. They were called Future House before. Sam Altman also talked about them, is Cosmos. So these organizations announced the first world model called Cosmos. And this is also supporting AI for science by allowing researchers not only to see what is all the prior work that was done, how do we write programs to explore solutions and use tools, but actually create simulations using models that were trained for the real world, like models that really understand molecular design and biology. So they have this entire system that can not only validate research hypotheses, but they can simulate future scenarios in very specific scientific domains. And I wanted to give you an example of how I used Cosmos. So how many of you have heard about ARC competition for testing models, ARC3, ARC-AGI? Have you heard about this? It's actually right now one of the hardest challenges for AI models. And it's a couple of puzzles. They look like that. So it's a couple of puzzles that are actually relatively easy, like humans can solve them. You have to think a little bit about it, but humans can solve these puzzles. The best AI models cannot, or struggle with it. Sometimes they can do it, but usually the success rate is below 50%, which is pretty low. So I'm using this ARC, the latest ARC3 benchmark, and showing that kids can solve it, right? And then trying to come up with new evolutionary algorithms to train models to solve it. And I created a lot of demonstration of how kids solve these puzzles. And then I gave all those demonstrations to Cosmos, and then it started to analyze, based on hundreds of examples of solutions and puzzles, what are the patterns, right? And what should we do? Like, what should be the path in order to create evolutionary algorithms that lead to models that can actually solve this type of puzzles, that have a better reasoning? They're not just trying to find patterns in large quantity of data. And I was impressed because it actually ran for an entire day. It created all these artifacts, all these simulations, and it gave me useful insights. So this is a tool that is very useful for me as a scientist. AI for science is also used for novel material science. So I wanted to give the example of periodic labs. This is actually started by Liam Fedus, who used to be one of the ChatGPT co-founders. And then they decided to, he started his own company because he wanted to push the frontier of how we design materials, and in particular, superconductors. Again, we go back to the sustainability challenge. How do we build better chips? How do we build better data centers? Like, go back to the basics, the fundamentals. So they're actually using AI to explore the space of material science and try to come up with a very fast pipeline from simulating different formulas to actually producing those materials in the lab and testing them. So I told you all of these AI scientist solutions and what exists. None of these systems work in real time. So if you are a scientist today that is doing experiments in the lab, you don't have a partner that you can ask questions to, like an AI partner that you can ask questions to. At the same time, we do have multimodal AI solutions that support real-time interactions. So we moved beyond text. We now have multimodal AI solutions that support image in real time, like image analysis in real time, video analysis in real time, sensor data analysis in real time. And why does that matter? It matters because it enables more natural interactions. It also matters because it gives us better answers. It leads to what is called grounding. When I ask a question, the system knows what I'm referring to, like, why is the reaction getting hot? It has access to the sensor data, so it can see exactly what are the values, what's happening, what's the temperature, what's the humidity, what's the concentration. So it will give me much more anchored answers in my situation, in my context. So my vision for AI for science is that we will actually create AI scientists that are buddies, there are our pairs that we could use in real time. Because when I'm doing an experiment, I want in real time to have like a support system that can detect anomalies in my data, that can verify my protocol, that can tell me if someone else has tried the same thing and it worked or it didn't work. Not at the very end, not at the very beginning. So here's the system that I built. It's called LabMind. So it actually allows scientists to describe their protocol and say, this is the type of experiment I want to run. It will generate the UI to match their protocol. So in this case, I was testing it by growing crystals. And then it allows them to also connect microscopes, sensors, any type of other equipment they have in the lab, and interact with the AI in real time, ask questions about what's happening in the different reactions. And there's a video that shows it in action. So the data is being monitored as the experiment is running, and I can also, as a scientist, send images to my AI pair scientist and ask questions like, what's happening? Is the crystallization nominal? Like, is it going according to my protocol? Are there any anomalies? Is the data increasing? Like, is the data behaving the way I would expect? So the system has this architecture. It allows me to have lots of different inputs from sensors, camera, video. It also allows me to, in the backend, connect to multiple data sources. So let's say I have a knowledge base that looks at all possible molecules for crystal growth, and it's going to compare with that. And this is the data flow for the system. Like, we have the physical sensors that I showed you. All the multimodal data is assembled into a context. And then we can swap the type of APIs or models we want to connect it to. This is how that's done under the hood. And it's extremely affordable, and all the hardware I used, it's actually open source, open hardware. So it's also portable. I can have a lab in a box. This is in my apartment in Tokyo. So it's an example of me being able to run an experiment that takes multiple days. Let's say I have like salty solution, and I'm slowly like cooling it off to create these crystals. I can let the experiment run overnight, and in the morning, I will come and ask or see what happened. And I will ask my system, like, when did the crystals form? Which of my conditions, like which temperature worked better? Which salt concentration worked better? So I can actually see a plot of my data after it recorded and ran overnight and ask these questions. I've done, this is another example with fermentation. We're going to skip through it. It's the same idea. And I wanted to show you, like, I mentioned that it's open hardware. This is called Recamera. So it actually allows me, it's built by Seed Studio, a company based in Shenzhen that do a lot of AI models that can run on device. And it allows me to use the system even without internet. The model can run on that tiny camera. I can train a custom model that tracks specific events or objects that will run on the camera. And of course, the future of science and scientific discovery is going to be AI supported. And that's not just for existing scientists and researchers, it's also for future scientists and researchers. So I created a version of the system that it can be used for education. And it works on a phone. So I tested this with kids. So there's a version like the future scientists, as they're learning science, they can also do their own experiments and get ideas for, I have this soap at home, what can I do with it? Or I have this leaf, why is it changing the color like this? Let's do some experiments and figure it out. And under the hood, it also has this knowledge base of misconceptions. What are common mistakes that people do when they use the systems or when they do scientific discoveries? So that knowledge base is plugged into the architecture, and when the student asks a question that shows they don't understand the scientific concept, it's going to get flagged to their teacher or their parent or themselves. And I evaluated the system against open source models to see how well it performs and if we could use open source models on the device itself. So Gemini at the time when I ran this evaluation was still the best model, but the open source models like the Lava were pretty decent. So I wanted to talk also about evaluation because I mentioned this term multiple times. This is an example of an open source evaluation framework that you could use in your prototypes or solutions. It's very important when we evaluate the systems, we often look at precision and how good, how accurate are the models at doing predictions, giving us the right answer. But using an AI for science assistant goes beyond precision, right? I care about how friendly that system is. I care about how good it is at identifying mistakes. I care about how coherent it is, how short the answers are, how age-appropriate the answers are. So all of these rubrics I can define because they give us a full picture of the experience, of the user experience. And then as I'm developing the system, I'm constantly running these evaluations. So the real-time AI scientist that I built is part of a bigger ecosystem of open source. People are building open bioreactors, they're building photoreactors, like basically every single piece of lab equipment that you can imagine in life sciences is being open sourced. And actually the Chan Zuckerman Foundation, like Mark Zuckerman and Priscilla Foundation, just announced they're going to invest $1 billion per year in the next 10 years for AI for science. So there are big bets that are happening in this space. And the future, what does the future look like? I showed you some very simple experiments that was safe for me to do at home. Of course, when you do this in industrial labs or science labs, they're more complex, they take longer. But the idea is that we should have systems that allow the scientists to be in the driver's seat, to do some experiments, but then I'll also allow them to go much faster. So based on the experiments that I'm trying, the system will create simulation. So instead of trying 1 or 2 experiments, I can try hundreds of experiments. And these experiments that are simulated are grounded in what is possible to do, what sort of molecules I can discover, what sort of drugs I can discover. They need to be realistic. They need to be able to be created in the world of bits and atoms, right? So to wrap up, my vision is that these AI co-scientists are going to become more and more prevalent, not only in life science domain, we're going to see them in lots of other domains, and they require to be integrated with physical operations and with human teams. Have like these pipelines to support real-time interaction, experimental frameworks, and safety sandboxes. And of course, like I mentioned earlier, the governance layer is very important. Like have ethical boundaries, what is okay and safe and ethical to do. Have human oversight protocols and continuous validation, continuous evaluation. So you probably know this by now, but I strongly believe as a researcher and a scientist that the future is not predicted. We're not living in a world only of prediction and pattern matching. We're discovering and inventing the future. And I hope we can do that better with AI and scientists collaborating together. Thank you so much.
네, 감사합니다. AI 변화의 흐름을 이끄는 미국의 구체적인 사례와 또 AI 기반 연구 개발의 혁신적 전략을 전해주신 스테파니아 드루가 연사님께 다시 한번 뜨거운 박수 부탁드립니다. 네, 이어서 캐런 문 스팽글AI 공동창립자 겸 최고사업책임자님의 발표가 있겠습니다. 버티컬 AI의 미래를 투자자와 운영자, 기업의 시각에서 다각도로 조망을 해주시겠습니다. 그럼 캐런 문 최고사업책임자님을 여러분들의 뜨거운 박수로 무대로 모셔보겠습니다.
안녕하세요. 문수경 캐런 문입니다. 저는 니거에서 태어났어요. 그리고 저 오늘 발표는 영어로 하겠습니다. 그래서 미리 이해해 주셔서 감사합니다. 그리고요, 이렇게 자리해 주신 이데일리한테 즐겁게 감사합니다. Okay, so in the US, about 88% of companies have deployed Gen AI. But only 7% are seeing bottom line results. So this is the Gen AI paradox. And today I'm going to give you a snapshot of what's happening in the US markets and also what the implications are for the agentic era that we're kind of very rapidly moving into, where vertical AI is at the core of the value chain and also where there's quite a bit of untapped enterprise value capture. So I'm going to share the lens from a holistic point of view. I'm a serial entrepreneur, an investor, and have, in my past startups and the current one, have worked with companies across the value chain that have generated over $300 billion in revenue. A lot's changed 10 years ago during the digital transformation age to today. And I think the Gen AI and agentic AI innovation is really interesting because it is rapidly led by enterprises and governments, and the adoption is just happening so quickly. So when we think about what the current state of affairs is, today the tech giants are battling on 3 fronts. One, they're defending their existing moats and economic power. They're capturing AI market share and moving really rapidly to figure out what's next. So the decisions made today on investments, partnerships were really very strategic in terms of who will win in the ecosystem. So I'm going to just walk through a few archetypes. First, we have our frontier model leaders, and these need no introduction, but it's really profound to see how rapidly OpenAI and ChatGPT have gained over 800 million weekly active users. They're expected to generate over $13 billion of revenue, and they're now have made infrastructure commitments of over $1.4 trillion across almost every player, like with commitments with all the key players in the ecosystem from an infrastructure standpoint. On the flip side, Anthropic has taken a very specific point of view around being the safety first and very responsible AI player. And they're also growing rapidly to about $5 billion in ARR. Next, we think about like the social media giants who actually have had the models and who actually have the moats around the data, but have launched a little bit later. And so the question is, their distribution is growing quite rapidly. You could see under 600 million monthly active users, et cetera, but the engagement is still not as low, and they still have a lot of room to capture. And so the question is, can they leverage their distribution moats? Can they leverage their unique data advantages that they have to kind of continue to win? And then lastly, you think about the infrastructure players. Obviously, NVIDIA is a huge market share, but what's interesting is they've made over almost 100 investments, multi-billions of dollars in just the last 2 years to kind of across foundation models, applications, and other infrastructure bets. And what's super interesting about what's happening here with the hyperscalers, with like Microsoft and Amazon, a lot's changed in the last 2 years. 2-3 years ago, there were exclusive, strategic partnerships where OpenAI and Microsoft, were led by the $13 billion investment, and they were exclusive to each other. That's changed, right? Microsoft just announced that they're going to deploy Claude in all of their Microsoft Office suite. Similarly, Amazon and Anthropic were working closely together, but now Amazon's also part of OpenAI. So as you can see, the shift and all the moves are just changing very rapidly. So what you can't ignore is how quickly this transformation is happening. And when you look at the launch of ChatGPT, it only took them 2 months to gain 100 million users, which is the fastest growth that we've seen across all these different social media and distribution channels. So what's interesting is the first mover advantage, which was not very long, but it was enough. That, the virality of growth, and also the product velocity, where they're really setting the pace and the standard for the rest of the industry, has been incredibly important for their distribution advantage. And so if you think about what drove that, we can't ignore this secondary economy and ecosystem that's developed around AI, where influencers, small business owners, consultants are basically educating the market around how to use AI, how to build businesses around that. And that's such an important piece of what is driving growth for OpenAI, Cursor, and all these different things, but all the new channels that will develop. And so I think this is just such an important piece to think about as we think about rollout of new technologies. So when we think about the last few years, it's the Gen AI era, let's say. What's happening is the models have tremendously advanced, and we still have a lot of room to grow. And I have to say, even if you look at the agentic mode for GPT 5.1 and 5.0, it's a dramatic difference, and it's only been a couple of months. But if you look over the longer term, the model quality is converging, And so, there's not as much difference from one model versus another. Mindshare is what drives adoption, and then UX and the stickiness of products and building features that people want and keeps them sticky to your platform is what keeps them there. So when you think about the adage of distribution versus technology, I think we're at the stage where distribution certainly compounds exponentially. But as we think toward the future, there's an opportunity for a reset. So if we think about 2023 as a Gen AI era, 2024 was about co-pilots. Well, this year was very much about agentic AI and agents, but we're still so early in that phase. And when you think about distribution as the advantage over technology, I think it's a little bit different now. Because now we're thinking about, Now it's like, when you think about agents and they have the capabilities to autonomously make decisions, we have to think about a few things that are a little bit different. Like a lot of this effort and innovation will be very much enterprise-led. We'll have to think about context, reasoning, security, and all of this to really jump to the next level, I think will be very much driven by corporations and larger budgets. And so this is an opportunity where actually the vertical players have another opening and the playing field can be somewhat reset. So where are we in terms of enterprise AI adoption? Well, this is a McKinsey report that was recently published, and we have about 88% of enterprises have adopted AI. Over 70% of Fortune 500 companies are using Microsoft Copilot, but there was a famous study from MIT published earlier this year that said 95% of pilots are failing. And that's mostly because of workflow integration, organizational readiness. So when you think about where we're at from an adoption standpoint, we're very much in the early days, which means there's a ton of opportunity. So when I look at this, I think in the organizations and where and how AI has been implemented, I think a lot of the value capture that's untapped has been driven by this imbalance between horizontal and vertical deployment. And it's just really where we're at in terms of the maturity of technology and technology adoption. So if we first define what horizontal means, that's like the co-pilots that are going across multiple functions, and vertical, where you're going end-to-end workflows from beginning to end and stuff like that, which is actually a really great opportunity for agentic to play. And so what should we do next? Right now, everyone's still in experimentation mode. About 7% of companies have really adopted where they're seeing impacts in the bottom line. So I think this is what McKinsey is calling the high performers. I think that's kind of a cohort to watch and learn. But also, we should think about the technology startups. Particularly in the US, tech startups are the fastest to adopt new technologies. And you can see in the last generations, significant trends of the companies that tech companies adopted very quickly have become market leaders in corporate. So as we are in this kind of new age, it's kind of interesting to watch where things are headed. What's also interesting about enterprise adoption is McKinsey actually also shared a report where they looked at 50 different deployments and looked at what was happening across each of those. The commonality was that there was an overemphasis, and the common pitfalls across these tests were that there was an overemphasis on the agent technology actually versus redesigning the workflows. So the amount of effort it takes to really capture value in the organization is to rethink everything about how we do things as humans, as computers, how we do it together. And so that takes a lot of effort. And so obviously it's hard, and the technology is advancing as we go, and so I think that's kind of an opportunity. But as I look at the future around vertical, this is the perfect example where startups and vertically integrated focused players have an opportunity. Because on one end, if you look at homegrown agents or like built consultants, like for example, Salesforce announced that they announced Agentforce, and their goal is to have 1 billion agents. So imagine a company with all these different homegrown agents where a manager can hire people, they can hire agents, they can, improve them as models advance, they have to update them, they have to evaluate them. Like, that's really hard to do. And so when you think about certain vertical players, the advantage is there's domain-specific knowledge and workflows. So an example, Harvey is an $8 billion player in the legal space. Abridge, $5 billion. They're like a health scribe that doctors use, and it's used in about 150 organizations. SpengelAI, it's a newer entrant, but we're focused on commerce. But the idea here is that you have companies that are innovating for very specific domains, and then leveraging the learnings across users in the industry, in the vertical, and at scale, and have dedicated R&D and learnings. So as we think about agentic, as we think about what's next, as we think about innovation, I think we can't ignore the concept of the jagged frontier. So this is a term that Harvard researchers coined in 2023. And basically the idea is it's really hard to predict AI. AI has intelligence of a PhD researcher, but sometimes the common sense of a kindergartner. And so what's different about this innovation wave is that the advancements can leapfrog, and they're not as predictable as last waves. So even though models are converging, even though at some point there's a diminishing marginal returns, there's always a next generation and a next frontier. So as an example, as we move toward AGI, the expectations will just evolve. As we move toward agent orchestration, as we move towards agent-to-agent ecosystems, these are the things to think about where actually in every wave there's an opportunity and the playing field is kind of reset. So just to move more quickly, so then we have AI agents, and I think the other thing that's super interesting that is really moving things forward, at least in the US, is that the MCP, so just for context, last year, late year 2024, Anthropic announced an open standard protocol called MCP, and that's actually really started to accelerate in terms of adoption. More middle of this year, OpenAI, Microsoft, and Google all have adopted it, but it's being proliferated in all of our applications, and that's going to help accelerate the agentic era. And then also you have on the orchestration, there's a lot of new, as we think about agentic solutions, there's so many other areas that we have to think about for our multi-agent coordination, and there's a lot of really cool startups doing some stuff in that space. So really quickly, as a case study, I want to talk to you a little bit about SpengelAI. So what we do is we work with brands like Michael Kors and Revolve, but we are thinking about what does the future of commerce look like today to help improve revenue and conversion, but also how to think about tomorrow. And I think there's, if you think about how we used to do personalization in the pre-agentic era, it was really about rules-based and certain algorithms. But now you have context, you have reasoning models and all this other stuff that you can do. But also, so much of the brand interaction is happening not on your own site, but from other sites. And that's a little bit about what we offer and where we're going in the future. But this actually applies to so many other verticals, right? People are interacting with healthcare, they're interacting with all these different elements of their daily lives, not in the one channel, but in all the channels that they're living in, whether it's TikTok, social media, or ChatGPT. So just to wrap up, we can't ignore what's happening in AI without understanding the capital flows that's driving innovation and growth. So actually, over 75% of the S&P 500 gains, which is the US stock market index, have come from AI stocks. And if we look at the venture capital landscape, over $160 billion, and this is just year to date this year, so just the first 9 months, but over $160 billion have been invested in US AI startups. That represents over 80% of global VC activity, and it's up 3x versus the 9 months the year before. So what's interesting about this is we're seeing a huge capital concentration in AI startups. And if you look over the last few years, a lot of the VCs have actually completely shifted their investment thesis to focus on AI. So it's not surprising that over 64% of total North American VC funding has gone to AI startups. And a lot of what's been driven by this is from sovereign wealth funds. So you have over $40 billion in sovereign wealth funds going into US startups, which is about 90%. The question here, though, is if you look at the chart and all the different countries, the question is, are we underfunding diversification and innovation in other areas? And so I think that's something that we're going to have to think about. Or are they all going to become AI native? Who knows? That is the question. And the one thing to keep in mind as we think about the resurgence of VC activity is actually, a lot of the problems and the challenges we see in the funding ecosystem from the pre-2021 era still exist. So up until 2021, where we really peaked in terms of VC activity, we're in a zero interest rate environment. we had a banking issue in the US and the market retraction. And not only until like OpenAI publicly came out with their ChatGPT and all their APIs have we seen a huge resurgence in VC activity. But if you look at this, and if you dig into the data a little bit more, 70% of capital is concentrated in late-stage companies. And if you look at the yellow line, which is pre-seed and all the way to early stage, like Series A and whatnot, it's actually 30% lower than our peak 2021 rates. So what's happening here? The growth has really been driven by the mega deals. OpenAI, Grok, et cetera, even like Cursor AI. And what does this mean for vertical AI? So essentially, there's a significant amount of competition. The bar's really risen for native AI startups. And there's certainly, at this stage, more infrastructure and horizontal advantage in terms of funding. And right now, I think VCs are still figuring out their thesis. Because OpenAI and other companies are starting to go into a number of different verticals, the question is, who's going to be alive and who makes sense in a world where they become like the horizontal winners? Sorry, my voice. So I think what's going to happen next is we're going to start to see increased M&A activity with a lot of the native AI startups, where there's a lot of domain expertise, talent, et cetera. There's still a lot of white space for infrastructure around agents, the orchestration layer, and still like actually quite a bit of application white space. So I think what's going to happen too is if you look at the funding, a lot of it, there's going to be outliers that really win in the space and lock in a competitive advantage because it's harder to get funding. And then we'll also see that's interesting in just the first 9 months of this year is that M&A activity is up considerably, which will give more liquidity for LPs. So what's the strategic window for Korea? And how is Korea going to be positioned to be a top 3 global AI leader? Well, I think what's really exciting and interesting about Korea is that it really has a unique advantage that many countries don't have. And so when we think about platform sovereignty, unlike other companies across the world, Korea is really dominated in terms of the domestic technologies. So Naver has always been a leader to Google, Kakao to Meta, and Coupang to Amazon. So I think we have this pattern already of being able to build homegrown leaders. Also, Korea has global industry leadership across many key sectors and deep domain expertise, and this ability to move extremely quickly. So when you look at distribution and trust at scale, when you look at domain expertise and the ability to verticalize, as well as speed and agility, like that becomes really exciting. So I think in terms of the next couple of years, there's still so much, we're still so early in where we're at from a technology standpoint that there's a lot of value to be captured. And I think some of the trends that we're gonna see in the next 24 months will be the continued expansion and standardization of MCP protocol. So it just enables more things to be interconnected. I think we're gonna see a lot of value coming out of enterprise software as it moves to the next stage and moves outside of experimentation. We'll see more vertical AI leaders emerge across key verticals, whether it's healthcare, commerce, et cetera. And I think there's a lot of untapped opportunities in orchestration and even agent-to-agent ecosystem, which is so early in the days. Even Google has a protocol that they announced recently. So these are my thoughts. Obviously, the world's changing so quickly. It's probably going to change tomorrow. But if you have any questions, happy to share more. Thank you. 감사합니다.
네, 데이터 기반 트렌드 분석을 통해서 미국 산업의 현재와 새로운 변화의 흐름까지 전해주셨습니다. 캐럿문 최고사업책임자님, 그리고 먼저 발표를 해주신 스테파니아 드루가 연구과학자님, 오늘 이렇게 멋진 포럼의 시작을 열어주신 두 분께 다시 한번 뜨거운 박수 부탁드립니다.